Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 2, which is the polynomials of NCERT textbook, and we'll try to cover the exercise 2.5. As you can see, I have written in the part 1 because the exercise 2.5 have total 16 questions, so we will divide the exercise into two parts. So this is a part number 1 for exercise 2.5, and this is session number 5 for this particular chapter. Myself, Deepak Gautam, teaching mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The chapter polynomial is divided into total 6 subtopics, out of which we have already covered the first 5 subtopics in the previous sessions. Okay, today we are going to start the 6th subtopic, which is the algebraic identities. Okay, so let's start. So these are there are total 10 algebraic identities in this chapter, which are listed here. You have already studied the first 4 identities in your previous class, that is in class 8. Okay, we'll do the derivation of all the identities one by one. Okay, so let's start. First we have x plus y whole square, which is equals to x square plus 2xy plus y square. Okay, we can write this x plus y whole square as x plus y into x plus y. Okay, now in order to solve this, what we're gonna do is, first we'll multiply this x with the x here, so this will be x square, then x with the y here, so this will be xy, then y with the x here, so this will be again plus xy, and plus y into plus y will be plus y square. Okay, then we have this x square, this xy plus xy will be twice of xy, then we have y square, which is the identity number 1, that is x plus y whole square is equals to x square plus 2xy plus y square. Okay, similarly we have the second identity, which is x minus y whole square is equals to x square minus 2xy plus y square. So we can write this as x minus y whole square can be written as x minus y into x minus y. Okay, now what we're going to do is, again we multiply this x with the x here, so this will be x square, then x with the minus y here, so it will be minus xy, then minus y into plus x will be again minus xy, then minus y into minus y will be plus y square. Okay, then we have this x square, this minus xy and minus xy will be minus twice of xy, then we have plus y square, which is the identity number 2, that is x minus y whole square is equals to x square plus minus 2xy plus y square. Okay, moving to the next one, we have x square minus y square is equals to x plus y and x minus y. Okay, whenever you have two variable in the square of two variable in subtraction, we can write them as, first add the two variable x plus y, then subtract the variable x minus y. Okay, we can prove this like, first write the right hand side term, which is x plus y into x minus y. Okay, now we'll multiply this x with the x here, so this will be x square, then x with the minus y will be minus xy, then plus y into plus x will be plus xy, and the plus y into minus y will be minus y square. Now this minus xy and plus xy will be cancelled out, so we'll remain with x square minus y square, which is the identity number 3. Okay, next we have x plus a into x plus b is equals to x square plus a plus b into x and plus ab. Okay, we can solve this like, first write the x plus a into x plus b equals to, again first we multiply x with the x here, so this will be x square, then x with the b here will be xb, then a into x will be xa, then a into b will be plus ab. Okay, now write this x square as it is. From these two terms we will take the x common, so we'll remain with x into b plus a plus ab. After rearranging the terms, we'll get x square plus a plus b. We can interchange the order of ba to ab and to x plus AB. This is your identity number 4. So these 4 identities you have already studied in your previous class, that is in class 8. Okay, now we have some new identities, which are starting from the identity number 5. We have the square of a trinomial, okay, which is x plus y plus z whole square is equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. So this is, we have x plus y plus z whole square. This can be written as x plus y plus z multiplied to x plus y plus z. Okay, now in order to solve this, what we're gonna do is first we multiply this x with all the three terms here. So we'll get, first x into x will be x square, x into y will be xy, and x into z will be xz. Then we have plus y into x is xy, this y into y will be y square, and then y into z will be yz. Then we have z into x will be zx, then plus z into y will be yz, then z into z is z square. Okay, now first we'll write all the square term, which is x square, y square and z square. So we'll write x square plus y square plus z square. Then we have plus xy and plus xy, so this will be twice of xy. Then we have yz plus yz, so this will be twice of yz. Then we remain with this xz and xzx, so this will be twice of zx, and which is the identity number 5. X square plus y square plus z square equals to 2xy plus 2yz plus 2zx. Okay, you can remember this like this. First write the square of the all three terms, x square, y square, z square, then twice of first two term this xy, then twice of second two term yz, then the twice of the third in the first term, which is zx. Okay, that's how you can learn and remember this identity. Okay, moving to the next one, we have x plus y whole cube and x minus y whole cube. These two are the very important identities. Let's understand them. We have x plus y whole cube. This can be written as x plus y into x plus y square. So here we have power 1 and here we have power 2. When you multiply them, again the part will be added, you will get x plus y whole cube. Okay, first now we will expand the identity 1 here, which is x plus y whole square. So we have here first x plus y, then we'll expand the identity here. This will be x square plus 2xy plus y square. Okay, now what we're going to do is first we multiply this x with all the three terms here. So we'll get x into x square will be x cube, then x into 2xy will be 2x square y, x into y square will be x y square. Then we multiply this y with all the three term here. This will be y into x square will be x square y, then y into 2x will be 2x y square. Then we have plus y into y will be y cube. Okay, now we can write this as x cube first, then y cube. Now we have this twice of x square y and 1x square y, so this will be 3x square y. Okay, then we have plus the remaining is x y square and 2xy square, so this will be again 3x y square. Okay, now from these two we can take 3xy common, so we'll remain with x cube plus y cube. After taking 3xy common, we remain with x plus y, and this is the identity number 6. Okay, I hope you have understood it. Similarly, we have the identity number 6. We have x minus y whole cube. We can write this one as x minus y and multiply to x minus y square. Okay, so this can be written as x into, first we'll expand the identity here. So we have x minus y, we'll expand the identity, so this will be x square minus 2xy plus y square. Okay, now we multiply the x with all the three term here, so we'll get x cube minus 2x square y, then plus x y square. After that we have minus y into x square will be minus x square y, then minus y into minus 2xy will be plus 2x y square, then minus x into minus y square will be minus y cube. Okay, first we'll write it as x cube minus y cube, and this will be minus 2x square y and minus 1x square will be minus 3x square y, and we remain with this xy square and 2xy square. This will be again 3xy square. Okay, from these two terms we'll take again minus xy common, so we'll remain with x cube minus y cube. After taking 3 minus 3xy common, we remain with minus x into minus x minus y, which is our identity number 7. Okay, moving to the next one, we have x cube plus y cube plus z cube is minus 3xyz is equals to x plus y plus z into x square plus y square plus z square minus xy minus yz and minus zx. Okay, we can verify this by taking the right hand side term. We have x plus y plus z multiplied to x square plus y square plus z square minus xy minus yz minus zx. Okay, first we'll multiply this x with all the terms in the second bracket. So x into x square will be x cube, x into y square will be xy square, x into z square will be xz square, then x into minus xy will be x square y, x into minus yz will be minus x yz, then x into zx will be minus zx square. Okay, this is after multiplying x with all the terms in the second bracket. Now we multiply y in all the terms of the second bracket, so we will get y into x square will be x square y, y into y square will be y cube, y into z square will be y z square. Then we have y into xy minus xy will be minus xy square. Okay, then y into yz will be minus y square z, then y into minus zx will be minus x y z. Okay, now we multiply this z with all the terms of second bracket. So z into x square will be x square z, then y square z, then z cube. After that we have minus x y z, then z into minus x will be minus y z square, and then last we have minus z square x. So this is after multiplying all the x three variable x y z in the second bracket. Okay, let's change the color of pencil. We have now green. Now you can see this plus xy square will be cancelled out by minus xy square. Okay, now this plus xz square will be this plus xz square will cancel the minus xz square. Okay, then we have x square y which is in minus, here we have x square y in plus. Okay, then my x square minus x square z, and here we have minus, where is it, x square z is here plus. Okay, now we remain with this yz square of plus and yz square of minus, and minus y square z and plus yz square will also be cancelled out. Okay, so now we remain with only three square terms which are x cube, this one, then we have y cube plus y cube, then we have plus z cube. Okay, and in the end we have this minus xy, minus xyz and minus xyz, so we'll have minus 3xyz, which is the identity number 8. Okay, moving to the next one. Now we have identity number 9 and identity number 10. So these are also very important identities. This will also be used in your future classes. Okay, and it is actually the question number 9 part 1, and this is the question number 9 part 2 of exercise 2.5. okay, but they are itself the identities. So now we'll verify these identities. We have x cube plus y cube is equals to x plus y into x square minus xy plus y square. Okay, now we have to prove these identities. We have this x cube plus y cube is equals to x plus y into x square minus xy plus y square. Okay, we can prove it by, we'll take this x plus y and x square minus xy plus y square. Okay, what we're gonna do now is we'll multiply this x inside the all three term of the second bracket. So x into x square will be it will be x cube, x into minus x will be minus x square y, and x into plus y will be square will be x y square. Then we multiply this y with all the three terms. So this y into x will be x square y, and y into minus xy will be minus x y square. Then y into plus y square will be plus y cube. Okay, now this minus x square y will cancel the plus x square y, and this plus x y square will cancel the plus x y square. So we'll remain with x cube plus y cube. Okay, this is our identity number 9. Then we have now the similarly 10th identity. We have x cube minus y cube is equals to x minus y into x square plus y square plus xy plus y square. Okay, now we can also prove this by x minus y. Now we have x square plus xy plus y square. Again we'll multiply this x with all the terms inside the second bracket. So it will be x cube plus x square y plus x y square. Then we have minus x into x square will be minus x square y, and y minus y into plus xy will be minus x y square. Then x in y into minus y square will be minus y cube. Okay, this plus x square y will cancel the minus x square y, and this plus x y square will cancel the minus x y square. So we remain with x cube minus y cube. So these are the all 10 identities. We have done the verification of all the identities. Okay, you can understand this now better. Okay, based on this all 10 identity, we have the exercise 2.5. Now let's start the exercise 2.5. So we are doing chapter number 2, polynomial algebraic identity, based on which we have exercise 2.5. So this exercise in total have 16 questions. We'll cover the first few questions in this first session, then remaining in the second part of this video. Okay, let's start with the first question. We have use suitable identity to find the product of the find the following products. Okay, so let's start. We have, let's write answer number 1. Part 1, we have x plus 4 into x plus 10. Okay, now after seeing the question, you have to identify which identity can be used here. We can use the identity number 4 here, which is, you have to write using identity x plus a into x plus b, which is given by x square into a plus b into x plus ab. So right, that is, we have x plus 4 into x plus 10. Okay, x here is x, a is 4, again x is x, and b is 10. Okay, so we'll write this as x square, that means square of variable term. Then we have a plus b into x. A here is 4, b is 10, into x is x. Then a into b, a is 4 and b is 10, so this will be x square. This 4 plus 10 will be 14, and 14 into x will give us plus 14x, and plus 4 into 10 will be 40. So that's the solution or the product of this polynomials. Okay, next we have part second. We have x plus 8 multiplied to x minus 10. Again you have to identify which identity can be used here. So again we can use, you have to write the identity which we are going to use. So write using identity. Which one? We will use identity number 4, which is x plus a into x plus b is given by x square plus a plus b into x plus ab. So write that is, we have x plus 8, no 10, 8 into x minus 10. Now you can see x here is again x, a is plus 8, x is again x, and b is minus 10. Okay, so we'll write this as x square, that means square of the variable term. Then we have plus a into b, a here is 8, b is minus 10, into x, x is again x, and a b means a is 8 and b is minus 10. So this will be square of x is, this is again x square. This 8 minus 10 is minus 2, so this will be minus 2x, and minus 10 into 8 will give us minus 18. So this is the product of the given polynomials using algebraic identities. Then we have part 3, which is 3x plus 4 multiplied to 3x minus 5. Okay, now again we can use the same identity, which is identity number 4. So you will write using identity. In every question you have to write or mention the identity which you are using. So we'll write using identity x plus a into x plus b is equals to x square plus a plus b into x plus ab. Okay, the more and more time you write this identity, you will learn and remember them easily. Okay, so write that is, we have 3x plus 4 into 3x minus 5 given by, now this time see, x here is 3x, a is 4, x is again 3x, and b is minus 5. So we can write x square, x here is 3x square, then we have plus a plus b, a is 4 and b is minus 5. Okay, then x here is 3x, then we have a plus b, again a is 4 and b is minus 5. So after solving it, you will get 3x square will be 9x square. This 4 minus 5 will be minus 1, minus 1 into 3x will be minus 3x, and this plus 4 into minus 5 will result into minus 20. Okay, so that's the solution of the part 3 of question number 1. So now we come to the next part, which is part number 4. We have y square plus 3 by 2 multiplied to y square minus 3 by 2. Now can you identify which identity we can use here? We can use the identity. So write using identity. We can use the identity number 3 here, which is x square minus y square is equals to x plus y into x minus y. Now you can see, first we have two terms in the addition, that is x plus 5, then they are in subtraction, that is x minus y. Okay, so we can write this as y square plus 3 by 2 into y square minus 3 by 2 will be equals to x is here, y here, this x is equals to y square and y is equals to 3 by 2. So we can write this as square of first term and minus square of second term. First term here is y square, that means square of y square, then minus square of second term, which is 3 by 2. Okay, I'm not using this sign here, so we'll write only the 3 by 2, keeping this minus sign outside as given in the identity. So the square of the y square will be y power 4, then minus we have 3 square is 9 and 2 square is 4. So the answer is y power 4 minus 9 by 4. Okay, now come to the last part of this question number 1. We have 3 minus 2x multiplied to 3 plus 2x. Again we can use identity which we have used in the previous part. So write using identity, we'll use x square minus y square, which is given by x plus y into x minus y. So this will be, that is, we have x, sorry, not x, we have 3 minus 2x and 3 plus 2x. So as you can see, first they are given in the addition here, then in subtraction we can write this as square of first term minus square of second term. So the first term here is 3, that is 3 square minus square of second term, which is 2x square. 3 square is 9 and 2x square is 4x square. So that's the answer of this part number 5 of question number 1. Okay, moving ahead to the next question, which is the question number 2. Now we have evaluate the following product without multiplying directly. Okay, you are asked to evaluate the following product without multiplying them directly. So again we'll use the algebraic identity to solve this question without actually multiplying the numbers. So first we have 103 multiplied to 107. Okay, we have to find their product without multiplying directly. That means we are going to use the algebraic identity here. So first we have to convert them in the form of algebraic identity. So this will be, we can write this 103 into 107 as 100 plus 3 into 100 plus 7. 100 plus 3 is again 103 and 100 plus 7 is again 107. Now you can see this is in the form of x plus a and x plus b. So you can write using identity we'll use x plus a into x plus b, given by x square plus a plus b into x plus ab. So that is this 100 plus 3 into 100 plus 7 is equals to, here you can see x is 100, a is 3 and x is again 100 and b is 7. So this is x square, x here is 100 square, then a plus b, a is 3, b is 7 into x, x is again 100, then a into b, a is 3 and b is 7. So this will be 100 square will be 10,000, then we have plus 3 plus 7 is 10, 10 into 100 is 1000, then we have 3 into 7 is 21. So the answer is 11,021 after adding the numbers. Okay, so we have found the product of these two numbers 103 into 107 without actually multiplying them. Okay, instead we have used the algebraic identity here. So let's try the second part of this question number 2. We have 95 into 96. Okay, this can be written as 100 minus 5 into 100 minus 4. 100 minus 5 is again 95 and 100 minus 4 is again 96. Okay, you can also write this one as, this 95 can be written as 90 plus 5 and 96 can be written as 90 plus 6. Okay, but we will use this part because it is convenient to calculate with the 100 rather than 90. Okay, so we'll write them in as 100 minus 5 and 100 minus 4. Now which identity can be used here? We can use again x plus a into x plus b. So right, using identity, we'll use x plus a into x plus b, which is equals to x square plus a plus b into x plus ab. So right, that is, we have 100 minus 5 into 100 minus 4. Now you can see x here is 100, a is minus 5, b is minus 4. So this will be x square, that means square of 100. Then we have a plus b, a is minus 5, b is minus 4. Then we have multiplied by x, x is 100, then plus a into b, a is minus 5 and b is minus 4. So this will be 100 square is again 10,000. Then we have this minus 5 and minus 4 will be minus 9. So this will minus 9 into 100 will give us minus 900, and this minus 5 into minus 4 will become plus 20. So the answer of this one will be, we have 10,000 minus 900 in is 9,100, and then we add the 20 is 9,120. okay, so that's the answer of the part 2 of the question number 2. Now we have 104 into 96. This can be done as 100 plus 4 and 100 minus 4. We can solve this using identity. We can use x square minus y square, which is given by x plus y into x minus y. So that is, we have 100 plus 4 into 100 minus 4. This is x square minus y square. X here is 100 square minus y is 4 square. 100 square is 10,000 and 4 square is 16. So the answer is 9,984. okay, so that's the solution of this question number 2. okay, we have found the product of the given number without actually multiply them. Instead we have used the different algebraic identities. okay, now come to the question number 3. We have factorize the following using appropriate identities. So this is very important question. Let's write it answer. Question number 3 part 1. We have 9x square plus 6xy plus y square. Now understand this carefully. okay, pay attention here. Now we will convert this. Now as you can see, all the term is with positive sign. okay, this look like in the form of x square, this look like in the form of y square, and this is in the form of 2xy. So first we will convert them into the identity number 1. So we can write this 9x square as 3x whole square. 3x whole square is again 9x square, and this y plus y can be written as y whole square. So this, our x here is 3x and y is y, and we can write this as 2xy, that is 2 into x is 3x into y is y. Now you can identify this in the form of x square plus 2xy into y square. So you can write using identity x plus y whole square equals to x square plus 2xy plus y square. So this will be, that is, this can be written as x plus y whole square. X here is 3x, y is y whole square. As the power is 2, we can write this as 3x plus y into 3x plus y. So this is the factor of this given polynomial. okay, using the algebraic identity number 1, which is x plus y whole square is given by x square plus 2xy plus y square. Now come to the second part. Now we have 4y square minus 4y plus 1. Now you can see we have this in the form of x square, y square, and this look like in the form of minus 2xy. So we can write these terms as this 4y square can be written as 2y whole square. Then we have this 1 can be written as 1 whole square. 1 power anything will again result into 1. Okay, in the between we'll write minus 2xy. X is 2y, y is 1. So now we'll write using algebraic identity. Using identity, which identity will use here? We will use x minus y whole square, which is given by x square minus 2xy plus y square. So this will be, that is this can be written as y square minus 1 whole square, that is x square minus y whole square. X is 2y and y is 1. Or we'll write this as x minus 1 into, sorry, 2y minus 1 into 2y minus 1. So that is the factor of this given polynomial. Okay, now come to the next part. We have part 3. We have x square minus y square by 100. So we can write this as x square as x whole square minus, this can be written as y square by 100 can be written as y by 10 whole square, because y whole square is again y square and 10 square is 100. Okay, so now we can use the identity. We have x minus y square is equals to x plus y, then x minus y. So that is, this can be written as x plus y by 100, not 100, 10, and x minus y by 10. So these are the product of this given polynomial. So that's how we can solve the question number 3 of this exercise. Come to the question number 4. You are asked to expand each of the following using suitable identity. Expand each of the following using suitable identity. We have answer number 4. Okay, part 1, we have x plus 2y plus 4z square. Okay, which identity can be used here? We can use the identity, right, using identity x plus y plus z whole square, which is given by square of first term plus square of second term plus square of third term, then twice of first two term, that is xy, then twice of next two term, which is twice of yz, and in the end we have twice of third and the first one, that is zx. Okay, all right, that is, we have x plus 2y plus 4z whole square. Now you can see x here is x, y is 2y, and z is 4z. So this will be first x square, x is x, then we have plus y square, y is 2y, then we have z square, z is 4z. Okay, then we have plus twice of xy, twice of x is x and y is 2y, then we have plus twice of yz, y is 2y and z is 4z, then we have plus twice of zx, z is again 4z and x is x. So now solve this one, you will get x whole square is again x square, 2y whole square is 4y square, plus 4z whole square is 16z square. Okay, now this 2 into x into 2y will be 22, will be 4 xy, and this 2 into 2 into 4 will be 2 into 2 is 4, 4 into 4 is 16 yz, and in the end we have 2 into 4 is 8 zx. So this is the solution of this given expression. Come to the next part. We have 2x minus y minus z whole square. Again we can solve this using identity. X plus y plus z whole square given by x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, so write that is, we have 2y minus y minus z whole square is equals to, first x square, x here is 2x square, then we have y square, y is minus y, then we have z square, z is minus z, then we have plus twice of xy, x is 2x and y is minus y, then we have plus 2yz, twice of y is again y minus y and z is minus z, plus 2zx, that is 2 into minus z into 2x. Now we'll solve this. 2x whole square is 4x square minus y whole square is plus y square minus z whole square is plus z square, then we have 2 into 2 is 4 into minus y is minus 4xy, then minus y into minus z will be plus, so it will be plus 2yz. Okay, then we have minus 2 into minus z into 2x will be 2 into 2 is 4, so it will be minus 4zx. So that is the solution of the question number part 2 of the question number 4. Okay, come to the next one. We have minus 2x plus 3y plus 2z. This is minus. Okay, we have minus 2x plus 3y plus 2z square plus 2z whole square. Okay, again we will use the same identities, right? Using identity, we'll use x plus y plus z whole square. Okay, we will use x plus y plus z whole square is given by x square plus y square plus z square plus 2xy plus 2yz plus 2zx. All right, that is we have minus 2x plus 3y plus 2z whole square will be given by x square, x here is minus 2x square, then y square, y here is 3y square, then z square, z here is 2z square, then we have plus 2xy plus 2x is minus 2x into y is 3y, then we have plus wait a minute, Okay, now we have twice of yz. Y here is 3y and z is 2z. Then we have 2zx, that is twice of z is 2z and x is minus 2x. So now we'll solve this. Minus 2x whole square will be 4x square plus 3y whole square is 9y whole square plus 2z whole square is 4z whole square. Then this 2 into 2 is 4, 4 into 3 is minus 12xy. Then we have plus 2 into 3 is 6, into 2 is 12yz, and in the end 2 into 2 into 2 is minus 8zx. So this is the solution of this last part. Okay, now I leave the fourth and the fifth part of this question. I'll do the sixth part. Okay, remaining two will be your homework. So part 4 and part 5 of the question number 4 are your homework. That is 3a minus 7b minus c square, and the fifth part is minus 2 plus 5y minus 3z whole square. So these two are your homework. I will do the sixth and the last part of this question number 4. Okay, after this we'll do the one more question, that is the question number 5 of this exercise, and we'll then stop this session and we'll continue with the question number 6 in the next video. Okay, so let's do the part 6 of the question number 4. We have 1 by 4a minus 1 by 2b plus 1 whole square. So we can write this as minus 1 by 4 can be written as minus a by 4, and minus 1 by 2b can be written as b by 2, then plus 1 whole square. So we'll use the identity using identity x plus y plus z whole square, which is given by x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, so I'll write that is we have minus a by 4 minus b by 2 plus 1 whole square. This can be written as, first we'll write x square, that means minus a by 4 square. Then we have y square is minus b by 2 square. Then we have z square, that is 1 square. Then we have plus 2xy. 2x is minus a by 4. Y is minus b by 2. Then we have plus twice of yz. Y is minus b by 2. Z is 1. Then we have 2 zx. Z is again 1 and x is a by 4. Now multiply the number, solve this. Minus a by 4 whole square will be plus a square by 16. Then we have plus minus b by 2 whole square will be b square by 4. 1 square is again 1. Then we have this 2 will be cancelled by the 2 here, so we'll remain with this minus will become plus, so this will be plus ab by 4. Okay, and here also this 2 will be cancelled out, so we'll remain with this 2 cancelled by the 2 here, so we'll remain with minus b. Okay, then again this 2 will give us 2 here, so this will be minus a by 2. So this is the solution of this part number 6 of the question number 4. Okay, now moving to the next one, we have question number 5. So we have to now factorize these given polynomials. So let's start the answer number 5. Part 1, we have 4x square plus 9y square plus 16z square plus 2xy minus 24yz minus 16xz. Okay. Now you can see this look like in the form of x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, so that means we can convert this in the form of x plus y plus z whole square. Okay, so we can write this as this 4x square can be written as 2x whole square, 9y square can be written as 3y whole square, 16z can be written as 16z square can be written as 4z whole square. Then this is should be 2xy, that means twice of xy. X is 2x, y is 3y. You can check when you multiply this number, you again gonna get 12xy. 2 into 2 is 4, into 3 is 12, x into y, that is xy. Then we have plus twice of yz. Y here is 3y and z is 4z. Okay, now you can see this is 24. 2 into 3 is 6, 6 into 4 is 24. Then we have plus twice of xz. X here is 2x and z is 4z. Okay, this is in the form of identity x plus y plus z square. But you will notice one thing here, that the sign here is minus and here also minus, but in the formula we have plus both side. Okay, that means one of the term, either this x, y or z, has to be of minus. Now you can see here we have variable x and y, and the sign in front of them is positive. Here we have yz, here sign is negative, and here also we have xz, so sign is again negative. So in both case we have z common and minus sign common. That means this term that which is of z has to be of minus. Okay, only then that this will satisfy. That means this z has to be minus 4z and minus 4z and minus 4z. Only then this will satisfy, because now when you multiply this you again get the minus 24yz, and similarly from here you will get minus 16xz. Okay, now we'll write using the identity. We'll use x plus y plus z whole square equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, so this will be equals to x plus y plus z. So x here is 2x, y here is 3y, and z is minus 4z whole square. Or this will be written as 2x plus 3y minus 4z into 2x plus 3y minus 4z. Okay, so that's the solution of this question. Similarly, we have the second part of this question. Okay, we have 2x square plus y square plus 8z square minus 2 root 2 xy plus 4 root 2 yz minus 8 xz. Okay, now again you can see this look like in the form of the identity x plus y plus z whole square. So this is our x square, y square, z square, then 2xy, 2yz and 2xz. Okay, now you will notice again one thing, that these two terms have root values, and which variable is common here is y. So that means the value of y has to be in root. Okay, the value of y needs to be in with root power. So now we can write this as this x square can be written, 2x square can be written as root 2x whole square. So this root 2x whole square will be again 2x square. Y square can be written as y square. 8 can be written as 2 root 2 z whole square. Now you will notice that these two terms are with minus sign and the variable common here is x. Okay, that means the variable x is with minus sign here. Okay, so that this will be, now we have 2xy. 2x is minus root 2 x into y is y, then we have plus 2yz. Y is y, z is 2 root 2 z, then we have plus 2zx. Z is 2 root 2 z into x is minus 2x. Okay, so now you can write using algebraic identity x plus y plus z whole square given by x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Here x is minus root 2 x, then plus y is y, and z is plus 2 root 2 z. whole square, or you can write this as minus root 2 x plus y plus 2 root 2 z. Okay, because you are asked to find its factor, so you will write it 2 times. Okay, so that's the solution of the part second of question number 5. So now we have covered the first 5 questions of this exercise, and also we have done the 9th question. Okay, so that's all from this session. We will continue this exercise in the next video. Okay, so that's all for now. We'll continue the remaining question in the second part of this exercise. Okay, now you can practice all the questions to understand them better. Okay, before that you have to learn and by heart all the algebraic identities. Okay, so that's it for now. Thanks for joining.